Good afternoon, everyone. My name is Dr. Rajni. Today we will discuss about the uh, plant pathology. Yesterday also we will discuss to this one. Now, hmm, yesterday we all are discussed about to the plant pathology discussions. All things are completed. Now, now we will discuss about to the symptoms of plant diseases. What type of symptoms are there in the plant disease? What are the introductions and classification of a plant disease? These are introduction. Plant disease is an important normal state of a plant that interrupts of modifies with vital function modified vital functions. A plant disease can also be defined as any problem with the plant leads to the reduction in a yield or appearance. Many plant disease are caused by the pathogen. Disease causing agents are called pathogen. A plant may be said to be diseased called pathogens. A plant may be said to disease when there is a harmful deviations from normal functioning of physiological process. These are the objectives you can study to the this unit able to classify the plant diseases to known condition necessary for pathogenic disease, identify various fungal, bacterial, viral diseases for plant by their symptoms. Classification of plant disease. On the basis of casual agents, the plant disease are classified into non-infection plant disease and infection plant disease. The first one, non-infection plant disease, they are not associated with any animate or pathos. So they cannot be transmitted from an infected plant to a healthy one. They are due to disturbance in the plant body caused by a lack of certain inherent qualities by improver environmental condition of soil and air and by the mechanical influence. For example, low and high temperature, unfavorable oxygen level, unfavorable water level, rain, wind, and air pollution, toxicity. These are examples for the non-infection plant disease. Second one, infectious plant disease. These are the disease caused by the pathogenic organisms or virus under a set of a environmental condition. Fungi, bacteria, virus, and nematodes are some pathogen. They obtained nutrients, water, and everything. They need to reproduce from their host fungal and viral pathogen cause many plant disease. Bacterial and nematode pathogen cause a few. Some pathogen can infect several kinds of plants. Others require a specific types of host. Pathogens such as fungi and bacteria differ in their ability to survive, spread, and reproduce. What type of conditions necessary for the pathogenic diseases? How to pathogen diseases to causing what type of conditions is must. The conditions are necessary pathogenic plant disease. A suspectable host plant is the first. Second one, active living pathogen must be present. Must be present. A suitable environmental a suitable environmental a suitable environmental for diseases for disease development. A sign of plants plant disease, physical evidence of the pathogen. Disease diseases plants diseases symptoms. The disease symptoms may the disease symptoms. The symptoms of plant disease is a visible effect of the disease on plant. Symptoms may be include detectable changes in color, the shape or function of the plant. It represent respond to the host. How to fungal disease symptoms are there? Symptoms are visible effect which pathogen includes on the host plant. Symptoms can be divided in two categories. One is the symptoms due to external appearance of pathogen or some part of the pathogen on the host. Mildew disease, rust disease, smut and burnt disease, sclerotia disease, white blister disease. Mildew disease, the pathogen is seen as a superficial growth on the host surface in the form of a patches of varying size. It is two types. One is a downy mildew. The second one is a powdery mildew. See these, you can observe these, the symptoms of the downy mildew. This is the stem, Cucurbitaceae family. This one, this is a powdery mildew cells. Powdery mildew disease. Downy mildew, powdery mildew. What is the difference in between the downy mildew and powdery mildew? Hmm. Downy mildewed pathogen is internal obligate parasite. The mycelium and sporangiophores are produced on the lower surface of the leaves, giving conty appearance. This is a downy mildew. Powdery mildewed pathogen is external obligate parasite. White powdery masses scattered over the surface of the plant parts. The powdery appearance is due to the formation of numerous conidia in the form of a coating on the host surface. For example, powdery mildew of Cucurbitaceae caused by the Sparotheca species. Coming to the second one is the rust disease. The rust symptoms Symptoms appear as a small colored postulated on host surface. Here, color may be red color, yellow color, black, brown, and orange color. These symptoms are produced due to the exposure of under underlining mass of the spore because of ruptured epidermis. Here, black rust of wheat caused by the Puccinia gramineous citrus. This is the rust diseases. These rust diseases is made important for the symptoms of mm, mutton floral organ, particularly in ovaries. The infected air look charcoal-like as the ovary as black powdery mass of smut spores instead of the grain. See here, this is the teletospore. These are the uridospores. Teletospores always black in color. Uridospores always red in color. What is the smut is different. Loose smut and covered smut. The smut also can be divided into two parts, loose and covered smut. The loose smut, the smut spores remain covered by the thin membrane in the beginning, but soon it ruptures and smut spores get exposed and disseminated. For example, loose smut of wheat caused by Yeastilago tristici. Covered smut, the smut spores remain covered by wall of the grain and gloom. They get exposed only at the time of the threshings. Covered smut of barley caused by the Ustilago hordeae. This one is a smut of covered. This is a loose smut and loose smut. This one is the covered smut is the infected grains. You can observe this one. In case of sugarcane, the whole floral axis is transformed into a black dusty whip. For example, whip smut of sugarcane is caused by Ustilago cytaminae. Ustilago cytaminae. In case of bunt, the smutted ear as a thick pericarp and ear given a stinking smell is there. Example, bunt of wheat is caused by Telita fiotida. See, this is a whip-like inflorescence. These are the spores is called the whip smut of sugarcane. Next one is the sclerotia. It is a compact hard mass of dormant fungal hyphae, which may be brown color, black color, grayish color, violet or purplish. In some cases, for example, ergot of rye, the sclerotia are formed in the position of keen in the spike. See, this is the sclerotium. The single sclerotium. This is one is a sclerotium, a single one. This is one. This is the enlarged symptoms of sclerotia. Next one, white blister. White shiny blister like pustulated are produced on the lower surface of the leaf of brassicle due to the exposure of white powdery masses of conidia. As a result of a rupture of epidermis, the example white blister or rust of crucifer is caused by albugo candida. See, this is the white pastulated symptoms, white blister. The symptom, second one, symptoms which are visible effect induced by pathogen and host. This is a necrosis, overgrowth, undergrowth. Necrosis in this death of the host tissue take place which is induced by attack of pathogen. Necrotic symptoms are follows lesions, lesions or leaf spot. If many cases necrosis is confined to small area and is called local lesinans, which may be bigger or small, circular, oval, or irregular in shape and variously colored. In many cases, dead tissue of the spot may fall out, leaving a hole. This is called the short hole. This is the short hole. Symptoms of lesinus or leaf spot. Wilt disease. Plant shows dehydration and drought. Drought symptom first appear in fleshy by shoot and leaves. The leaves become flaccid due to the loss of turgidity and result in the dropping of entire plant. Pathogen attack the root of the plant and get accumulated in the vascular tissue of the stem and root. It causes obstruction to the movement of water. Tylosis are also formed in the lumen of vessel. Beside this pathogen creates some toxic substance such as the gum, gel, pectic and polysaccharides. This is a symptoms of wilt disease. This is a stem and the after disease the leaves are the wilt fall the leaves and damping off young seedlings. The young seedlings are killed either before their emergence form the soil or after emergence. When they are killed before emergence, it is called the pre-emergence damping off, in which young radicle and plumule get rot and finally die. When newly emerged seedlings are killed at ground level, it is called post-emergence damping off. In this, the pathogen attack the base of stem hypocotyl, usually just below the soil line. The infected tissue becomes soft and water-soaked. As a result, the seeding topless over or collapse. This is the symptoms of damping off. Rot. This is the in the rot the affected tissue die and undergo decay. The rot disease may be classified on the basis on the organ attacked, such as leaf, stem, root, bud, and fruit rot. In rot, the death and decay is due to disintegrations of the cells and middle lamella by the action of enzymes. It turns back to brown, black to brown. Rot may be soft and dry. When symptoms is watery, it is called a soft rot. Blight disease, the symptoms give a burnt appearance, sudden and intensive damage to the leaves and other part of the plant is response to attack of the pathogen. Initially, symptoms appear in the form of a circular or irregular spot on the leaf, grass usually. It increases in size and cover entire leaf. The affected tissue become necrotic and gives burnt appearance. Inserts attack leaves, swivel and fall down. Example, late blight of potato caused by the Phytophthora infestis. Early blight of potato caused by Alternatia solani. This is a potato leaf showing late blight symptoms. This is the late blight symptom. A potato tuber showing a late blight symptoms also. This overgrowth, sometime overgrowth in the host tissue are induced which may be either due to hypertrophy or due to hyperplasia or due to both. In hypertrophy, the abnormal increase in size of the one or more organ of a plant is due to increases in cell size of host plant induced by pathogen. In hyperplasia, the abnormal increase in size of the one or more organ of a plant is due to increase in number of cells of host plant induced by the pathogen. Hypertrophy and hyperplasia causes destroyness, swelling, leaf curls, and galls. For example, hypertrophy of brassica caused by the albugo. This is a hypertrophy caused. Undergrowth, atrophy. Symptoms are characterized by undergrowth or underdevelopment of tissue. It produced drafting symptoms in which size of leaf reduce, nodes and internodes become short. Plant fails to produce flower and fruit and finally die. The little leaf of brinjal causing mycoplasma. That is the symptoms. Next one, bacteria. Complete the fungal diseases symptoms. Coming to the bacterial symptoms. All plant pathogenic bacteria are rod-shaped bacteria. Majority are flagellated. Only two genera among the six, for example, Corionobacterium and Streptomyces are gram-positive, while the rest are gram-negative. The pathogenic bacteria enter into the plant through root hairs, stigma, second one, natural openings, such as the stomata. Third one, incidental wound after entering into the suitable host. The bacteria may establish themselves intercellular, intracellular, intravascularly, or in more than one combination and exhibit following type of disease symptoms. Local listeners. Local listeners are spots appearance on the leaf blade, in the petiole, stem, etc. When such spots occur on fruits, resulting in the discoloration of fruit. The spot first appear at the minute water-soaked speaks, spreading rapidly to form irregular, angular, or circular spot. The lesionous or spot become necrotic, dead, and soft rods. In this case, softening of host tissue occurs due to the disintegration of cells and dissolution of the middle lamella as a result of enzymatic action and oozing of watery creations from the affected part. It is followed by the plasmolysis and death of the host cell. The bacteria grows upon this dead plant tissue. Next one is the cankers and scraps. Citrus canker is the best example. Canker and scabs are crocky outgrowth formed on above ground parts of the host, such as leaves, twig, fruit. These outgrowths are the result of the reaction of host tissue to the pathogen. The canker in dipple-seated local dead lesions result in the open wound sunken in the stem surrounded by living tissue. Scab, on the other hand, are not deep-seated because it is formed by epidermal infection. Such infections are common in citrus, mango, and many other fruits and forest trees also. The best example, citrus canker disease caused by the Xanthomonas citri. This is one. And tumor and galls. In some cases, in the invasion of bacterial pathogen result in the hypertrophy and hyperplasia of invaded tissue. This hypertrophy and hyperplasia is due to some chemicals produced in the vicinity of the host cell as a result of chain of reactions caused by the pathogen. Due to these, tumors and galls develop on the affected organ. Crohn gall disease caused by Agrobacterium tumefacius in the best example of these tumors and galls. Next one is the vascular disease. In some of the bacterial leaf spot, pathogen moves into the vascular tissue and becomes systematic. In other, the invasion is concentrated in the vascular tissues, resulting in typical wilt of the affected plants. Pathogenic infection obstruct movement of water in the vessel due to deposition of gum and formation of tylosis in the lumen of vessel. The collapse of vessels also contributing to the wilt. This is the total bacterial diseases. Coming to the viral diseases. The viral disease, first one is the hmm, leaf curl. Curling distortions and reduction in the size of leaf is produced by virus. Leaf curl of papaya is caused by tobacco virus. This is the next symptoms of leaf curl of papaya. Coming to the color changes. Color changes. Natural color of the plant changes due to attack of the virus, which are following many types. The first one is a mosaic. Characteristic light and dark green pattern accompanied by the blistered appearance of leaves. Blister appearance of leaves due to rapid growth. Due to rapid growth of dark green tissues. It is caused by the viruses. The best example, tobacco mosaic viruses disease caused by Nicotiana virus. Chlorosis. In this, yellowing take place in the leaf. Mm. Vicnic Visin cleaning. This is the yellowing of vein Beanleg takes place as a result. Uh, hmm. In this westerner is followed by the chlorolysis and leaves. And next one is the vein banding. This tissue close vein remain green, but remaining tissue undergoes chlorosis. Chlorosis. Next one, local listen. Local lesson. The symptoms appear in the form of a chlorotic necrotic small area. Necrosis is uh, killing of cells and tissues. Tissues are areas. Area where necrosis necrosis occur in the call lesson. Distortion. The infected plant shows the attraction in the summary of leaf arrangement. This one leaf arrangement. They clink their enrolling and resulting of leaves by the rating growth of veins. In some cases, the leaves get cleared or very called witches brooms. Next one is a ring spot, rounded spot which appearance on the leaf either single or in cluster, either single or either single or in cluster. There are a cluster of four to six leaves. These 4 to 6 leaves are called 4 to 6 leaves. The spot enclosed necrotic tissues. This one, which this one against into the dark green colored. And next one is the outgrowth and tumor. Outgrowth and tumor. This in certain cases plant develop into the plant develop plant develops outgrowth due to attacked virus. Secondary leaves are developed on the midribs of the leaves root develop tumors. Next one, color brick. This one, some viral disease produced colored spot, streaks, floral petals, and fruits. This is called color bricks. Here, yellow streak in tulip, where the tulip is there, yellow leaves of the tulip. And next one, pink color of Giardis, chlorotic spot of fruit of tomato. These are the bacterial. In some fungal, bacterial, and viral diseases, for example, fungal diseases, damping of seeding, Pythium dibarianum, the young seedlings of root from the base of toppler over. Downy mildewed crucifera, downy mildewed Peronospora brassica, small or large purple brownish spot on the ventral surface of leaf. Next one, downy mildew of cucurbits, pseudospera cubenensis, pale yellow angular patches on leaves. Downy mildew of the bajra, Sclerospora graminicola, the whole inflorescence into leaf braided structure without bearing any grains. Next one is the powdery mildew of wheat. Erispea graminae. This one is the grayish white powdery growth occurs on the leaf. Next, powdery mildew of peas. This is the Erispi polygone. This one is the powdery mildew. Powdery mildew with powdery with its spot completely covered the leaves, petiole, stem, petioles, stem, and powdery white is the petiole stem and even pods also. Mm, Next one, white rust of cucurbiturus. Okay, albugo candida, white or creamy, yellow colored postulates appear on the leaf. Black stem rust of wheat, Puccinia gramineus titrice. This one, black colored postulated appears, see leaves of the sheath. Hmm. Next one is the irregularly disturbed on the leaves. Yellow rust of the wheat. These are all diseases, different fungal and bacterial diseases. These are the bacterial and fungal diseases. Coming to the next one, how to control of the plant diseases. Here, how to control the plant disease. Plant disease play an important role influencing the agricultural economy. Therefore, the main objective of disease controlled uh, the, the main objective of disease controlled it is prevent qualitative and economic losses of crops due to attack by the pathogen. The aim of control measure is to save the population rather than a few individual plants. The cost of control measured used in the disease control should be less than the economy value of the crop. Various types of pathogens are present in nature. Their complete eradications is impossible. Therefore, plant disease control programs are uh, essential and should be operated in large areas, inserted or small areas. Objectives after studying this unit will be able to various methods of disease control, mm, prophylactic measure of protecting plants from disease, therapeutic measures for disease control after infection, the immunization measures for disease control, how can reduce economic loss agricultural due to the disease. Various methods control the plant disease can be classified. First one, methods of control. Methods of control, prophylatic or preventive measures. Second one, therapeutic or uh, uh, curative methods, immunization measures. And second one is the uh, prophylactic or preventive measures, exclusion, eradication, protection. Exclusion, quarantaries, field sanitization, roofing, and these are the one. Exclusive indicates it includes some regularly measure to keep away the entire pathogen in the areas where suspectable hosts are growing. This can be achieved by quantitative quarantines and quarantine regular of the plant qualities. The quarantine or quarantine regular plant quantities. This one quarantine or quarantine regulations or plant quarantine is the legal restrictional at the national and international level on the movement of agricultural commodities. The purpose of this regulation is exclusion, prevention, or delay in the spread of plant pathogens and disease in the uninfected areas. Quarantine measure three types: domestic, internal, and total embargoes. The first quarantine laws were enacted in USA in 1912 and are known as Federal Quarantine Act. In 1914, India had passed in her legislate the Destructive Insect and Pest Act, DPACT, which subsequently supplemented by other provisions. This act has been revised 8 times from 1930 to 1956 and corrected up to 1967, but it still does not fulfill the needs under prevailing condition. The DIP Act imposes restriction on import and export of the diseased plant materials and pathogen. For this purpose, there are quarantine station which works at seaports, airport in India. There are 4 quarantine stations operating under the Directorate of Plant Protection and Quarantine. 8 quarantine stations are at seaport, 6 at airports, 2 and land founderies. Hmm. This is the Sukhi in the Darjeeling district. DIP Act allow important of plant or plant material such as seed, tuber, etc. from other countries only when it has a certificate from the Ministry of Agricultural of the exporting country stating that the plant or plant material is free from pathogen. The imported material is thoroughly checked by the trained staff at quarantine stations. In this way, quarantine regulate entry of pathogen, uninfected areas and prevent the disease. Before DIAP Act following diseases, this is the leaf rust of coffee caused by Hemilia vestradix introduced from Sri Lanka. Late blight potato caused by Phytophthora infestans, Europe. Flax smut of wheat caused by Eurosis triticale, Australia. Downy mildew of grapes caused by Plasmospora viticola Europe. Downy mildew of grapes caused by Plasmospora viticola Europe. Downy mildew of cucurbitaceae caused by Erisiphe cicoreacum Sri Lanka. Downy mildew of maize caused by the Sclerospora philippines Java. There are a number of DIP Act as a result. Many diseases have been introduction in India also. Paddy blast caused by the Pyricularia oryza southeastia. Powdery mildew of rubber caused by Odium hevia Malaysia, Malaya. Black shake of tobacco caused by Phytophthora nicotiana Duchess. Crown gall of apple and pear bacterial disease in England. Hairy root of apple bacterial disease England. Bunchy top of banana viral disease Sri Lanka. What disease of potato caused by Syncryterium endobioticum Netherlands. Onion smut caused by Eurobitus capsula Sepsilia Europe. Golden nematode of potato caused by Heterodera rosestiana Europe. In India, so far quarantine measure exist for two insect pests, fluted scales and santos scale, and for three disease, wart of potato, bunchy tap, and mosaic of banana. Eradications, the primary aim of eradication is to break the infection chain by eliminating the pathogen. Thus, the production of initial inoculum is reduced by destroying on interacting the source of initial inoculums. For this, the knowledge of the life cycle pathogen method, penetra- uh, perinations, host range, and habit of growth essential prerequisites of division suitable. Field sanitization, rowing, eradication alternate host, eradication collateral host. Field sanitization. Field sanitization is very simplest method of disease control. Pathogens survive or penetrate through dormant structure in plant organ and in the soil, which act as a inoculum for disease caused by them. Hence, hence, field sanitization is must in which disease plant are eliminated by and destroyed. Destruction of disease plant is done either mechanically or chemically. Mechanically, the plant debris having inoculums and infected plant parts are burned after removal. Chemically, they are treated with suitable chemical to kill or inactive the inoculum. In fact, sanitary conditions are helpful in all infection diseases. Many infection diseases like powdery mildew of wheat and pea, downy mildew of wheat and pea, wilt of cotton and red rot of sugarcane can be controlled successfully by field sanitations. Rogging. Rogging is careful removal and destruction of infected plant parts from the field at the early stage. This method is applied in disease like loose smut of wheat, red rot of sugarcane, ergot of bajra, wilt of arha, loose and covered smut of barley. Eradication of alternate host, the heterogeneous pathogen complete their life cycle on two hosts, the primary host and secondary host, alternate host. This alternate host is generally wilt and provide shelter to the pathogen during the unfavorable condition. The eradication of such a wild host plant breaks the chain in the completing the life cycle of pathogen. For example, Fuxinus graminis tritrici is a heterogeneous pathogen and require two hosts, wheat and barley, to complete their life cycle. This pathogen causes black rust disease only on wheat plant, the eradication of barley plant. The alternate host in temperate countries breaks the chain of life cycle of pathogen. It helps in the control of black rust disease of wheat. Similarly, the yellow vein mosaic of lady's finger persists on the wild host in nature, and the systemic removal of these hosts help in the control of disease. Eradication of controlled host. Sometimes pathogens survive on wild perennial plants or grasses. They are called collateral host. For example, blastorise of disease caused by the Pericularia oryza. This pathogen can infect and survive on several wild species of rice and grasses, such as Panicum ripanus, Digitaria margiata, and Steria intermedia. This removal of these controlled collateral host from the area eradicate the pathogen and help in disease control. Coming to the protection. In protection prevention, preventive measures are applied to discourse the spore germination, penetration into the host disease development. It is achieved by using following method. Crop rotation, first one. Second one, selection of the good quality plantation material. Third one, condition for germination and emergency of plant. Crop rotation is an ancient farming practice that has been used by farmer science, that is called the BC centuries. Curl 1963 has revived the control of plant disease by crop rotation. Crop rotation is the practice of planting different crops subsequently on the same plot of land to improve the soil health also. Continuous growing of the same crop or related crop leads to the continuous increases of the soil-borne pathogen in the field. These soil-borne pathogens of the crop easily penetrate in the soil and increase their population. Ultimately, the soil becomes so heavily infected with the pathogen that is no longer support to the growth of the crop. Such soil is called sick soil. Similar crops tend to have the same pathogen. Therefore, crop rotation intercepts the pathogen life cycle and their habitat. The reduced survival rate of pathogen in the absence of the suitable host. Many soil-borne diseases such as wilt or rahar, wilt pea, red rot of sugarcane, ergot and smut of the bajra, etc., can be controlled by crop rotation. For example, Fusarium oxysporium causes wilt disease in arhar. They survive in the soil. To control this non-suspectable, other crops are sown in the field for the next 3 to 4 seasons. As a result, the chain of pathogen cycle break down to the absence of suitable host. Thus, disease can be controlled. This method is also important other aspects. Hmm. If the same crop is sown year after year in the same area, the particular essential elements of the soil will be exhausted. With the accumulation of toxic substance, and organic acid. That's why the rotation of crop helps in the disease controlled by increasing soil nutrient and limiting the concentration of pathogen in the soil. Next one, selection of good quality planting material. The seeds, tubers, cutting of plant grafts and used as a planting material. Proper care should be taken during the selection of above planting material because if planting material will be infected, then the crop will be diseased. Condition for germination and emergence of plant. Plant should not be shown when the disease pathogen is prevalent in that area. Showing of the seed should be done at proper time and proper depth. The appropriate fertilizer should be given at proper time. All above result in vigorous seedlings which has capability to fight the pathogen and protect them from disease. Injury in the plant should also be avoided during managing crop in the field to check the entire pathogen. This will also protected crop from the disease. Therapeutic or curative measures. Therapeutic or curative measures have been used much often be controlled plant disease than in human or animal medicines. The therapeutic inhibits the development of disease syndrome in the when applied for the treatment of diseased plant or plant parts. This is a physical therapeutic, chemical therapeutic. Physical therapeutic, in this diseased plants are treated treated with physical agents like temperature, radiation, and in the following way, sterilization of soil heat. In this method, soil in the field is sterilized by the steam 82 degrees centigrade or above for 30 minutes. This kills the soil pathogen, but it can not be applied in field of large areas. This method is effective as well as economic in greenhouses and seeds bed where the area is very small. Therefore, soil pathogen of greenhouses, seed beds are killed by steam sterilization also. And the second one, hot water treatment. This method is used to eliminate seed-borne diseases. The infected seeds are first stoked in the water of normal temperature. This result in activation of dormant inoculum of disease causing pathogen. Then seeds are immersed in hot water 54 degrees centigrades for 10 minutes only. This will destroy the pathogen, but the embryo present in the seed remains safe. The treated seeds are dried before showing. Thus, the infected seeds become pathogen-free and gives rise to healthy plants on showing. Next one, hot air treatment. This treatment is given to the plants after harvesting to remove moisture and protect them from fungal and bacterial attack. And low temperature treatment. It gives to control post-harvest disease of fruits and vegetable. Radiation treatment. Many pathogen of post-harvest disease killed by using radiation, such as ultraviolet, alpha, beta, gamma, and X-rays. Chemical therapy. In chemical therapy, chemical substance are used to kill the pathogen for diseases control. A variety of chemicals are available that have been designed to control plant disease by inhibiting the growth of a by killing the disease causing pathogen. Chemicals used to control bacteria, fungi, and nematodes may be applied to seed, foliage, leaves, flowers, fruits, or soil. They prevent or reduce the infection by utilizing various principles of the disease control. Enormous literature is available on chemical used for control of plant disease like principle of fungicidal action, horsefall, fungicide, advanced tree site in 2 volumes of Targosan, plant disease and their chemical control discussed Evans fungicide moderated the use of the chemical sprays, dust, seed treatment for protecting plants from the ravages of the pathogen is not innovation of the 20th century. In the past, agricultural chemical and fungicide to control the plant disease. The first recorded mention of the plant disease control is in the writing the Greek poet Homer, who mentioned sulfur, which is still is used fungicide. Hmm, Middle showed downy mildew of grapes could be controlled by mixture of copper sulfate and lime. Copper sulfate had been in use even before that, but its toxicity was reduced when mixed with the lime in 1885. The Bodex mixture was used European countries, USA, for control many disease. It was followed by lime sulfurs in the late 19th century and formulation copper carbonate dust and organomericulates as a seed treatment 1930 an area of organic fungicide therams and the chloranyl diclone were developed from the mid 1930s onwards and captain the most successful fungicide was developed only 2 decades ago. Many groups of chemical compounds are now available for plant disease control. These include heterocyclic nitrogen compound, quinines, quinines, phenols, and antibiotics. Fungicide. The fungicides are chemicals that kills or inhibit the development of the fungal spore mycelium on the basis of their uptake by the plant and mobility within the plant tissues. The fungicides are classified into um, protectant, eradicant, therapent. Protectant fungicides are porphyletic in their behavior and may be applied to seed, plant surface, or the soil. Fungicide of this category place a chemical barrier between the plant pathogen between the plant pathogen these fungicide are not absorbed by the translocated through the plant. Thus, they protect only those parts of the plant treated before the invasions by the pathogen. Eradicant the dormant or active pathogen from the host. Eradicants are designed to kill the pathogen that may be present in the soil, on the seeds, on vegetative propagative organs such as bulbs, corm, and tubers. They can remain effective on or in the host for some time and function as a protect also. Therefore, this chemical can be protect as well as the eradicant. Therapeutins inhibit the development of a disease syndrome in a plant when applied subsequent to invasions by a pathogen. Usually, the chemotherapeutic are systematic in their action. They entire the plant affected deep-seated infection. To be successful, fungicide must be following to be effective against rain and dew. Must be nearly insoluble in water, but at the same time, they must be soluble enough to function as fungicide. Adhesive is needed to enable them to seek well and last for a longer period should not be phytotoxin. On the basis of chemical nature, fungicides are divided in two categories, inorganic and organic fungicide. Inorganic fungicide chemicals used fungicide are known as inorganic fungicide, which may be copper compound, mercury compound, sulfur compound. In our Borax mixture, it was discovered middle late in 1985, University of Bordeaux, France. It is a mixture of copper sulfate, lime, and water. 1882, Milaret was investigation disease downy mildew of bean caused by Plasmopara viticola. He observed that the infected leaves had borne and get defoliated. But when the leaves were sprayed with Bordeaux mixture, the defoliation stopped. Then Milrate, in the collaboration with a chemist Guyan, was able to announce the successful use of copper sulfate, lime, and water fungicide against Plasmospora viticola. The fungicidal action is due to the formation of soluble copper sulfate, which is toxic to spores and sporulin in drops of atmospheric water. It is specific against downy mildew, late blight potato, coffee rust, and various leaf spot of diseases. The Borax mixture is sometimes phytotoxic to tender leaves and other parts and burn them. The formulate for the Borax mixture vary. The original mixture contained 15% copper sulfate, 8% lime. The proportion of these non-various according to the crop and the disease. Crop and the disease. Higher concentration are useful in the case of woody and throat tissue, while lower concentration are used for succulent and softer parts. The following formula is there. That is the copper sulfate blowstone for 51B 2.268 kgs and stone hydrate lime 2.260 kgs, water 50 gallons. The two solutions are prepared separately in wooden or other vessels and diluted solution of CuSO4 is slowly poured into a concentrated lime solution in a tube with constant stirring. The resulting mixture is natural or slightly alkaline and is not injurious. The mixture is used almost immediately after preparation and deterioration in left for the time. The avoid this stock solution of the two integrates can be prepared separately and stored in the wooden vessels. These can be mixed when actually required. Next one is the one, mm, Burgundy mixture. Burgundy mixture is a modification of the Borax mixture. It is used in case of tender foliage since it is less phytotoxin. In this, the lime is substituted by sodium carbonate and hence is sometimes called soda bodex. The composition copper sulfate 4.536 kgs, stone or hydrate lime 5.66 kgs, and water is the 50 gallon. This one is the quiescent casonate component. The contain 2 parts of copper sulfate and 11 parts of ammonium carbonate. It is used for the control of damping, damping of disease. Next one, cucurbite, kahubite paste. Next one, the paste is the prepared by mixing copper sulfate, red lead, and in 1 liter lanolin or raw linseed oils. Insoluble copper, the the fungicidal and bacterial properties of the copper is a copper is a used variety of copper ducts spray such as the Prinox and Biox uh, phytolon. Inorganic mercury compound. Mercury compounds are highly effective as fungicide and bacterium, there are but their use is a limited because they are highly toxic to animals, human beings. Mercury chloride, mercurous chloride are used fungicide in for seed, rhizome, corn of vegetables, flowers to control and certain and certain bacterial and fungal disease. Sulfur spray. The effective use of sulfur as a fungicide was discovered in the beginning of 19th century. Sulfur is the earliest known and widely used fungicide. The preparation of elemental sulfur, crude lime sulfur, used to control powdery mildew on the variety of crop, leaf curl of peach, the sulfur sprays, etc. Lime sulfur, chemically lime sulfur is a mixture of calcium, the sulfate, and calcium polysulfate both. Besides fungicide, it is a it is a inside the on the tender part of the inside the tender part it is a phytotoxic, hence it has only limited the use. Self boiled lime sulfur, this is the less toxic thin lime sulfur and made by using 81B sulfur for and 81B burnt lime with 50 gallon of water. Wettable sulfur, also known as flotation sulfur, are are very finely divided elemental sulfur. It is extensively used large used large used for the injury. Organic fungicide. The organic chemicals used fungicides are known as organic fungicide. Organic compounds, quinone, phenolic fungicide, heterocyclic nitrogen compound, benzene compound, systematic fungicide, antibiotics. Some organic compound used as the fungicide. Thiram, tetramethyl, thiram dispersal. This one theorem is beginning sold under a variety of other trade names such as Arsaran, Tanda, Tersan, and Tulisian, etc. It is used for seed treatment. Theorem is also used in the control of foliage disease and the soil-borne pathogens such as Pythium, Rhizoctina, Fusarium, protomycin. Next one, ferbam, ferric dimethyl dithecocarbonate. It is a trade name is Fermate or Ferbe. Ferbe has been successfully used as a protect fungicide against wild variety fungal disease of fruits and vegetables. Ziram, zinc, dimethyl dithecocarbonate. It is a trade names are cumin, gyralate, carbam, white, corace, etc. In India, it is available under the trade names of cumin and used against many foliar disease in the field and orchid crops. Next, Gineb, zinc, ethylene, bis carbomate. Ginab is derived by the substitution of sodium in the nabam with zinc. It is also called dithane. Z878, this one. Quinone and phenolic fungicide. Quinone and phenolic compounds are quinone important of the fungicide. Some importance ones are chloranil, tetrachloro B benzoquinone. It was reported by Cuminogam and Sarwell 1940 to give protection the lime beam seedlings from the damping of chloronil is mainly used seed bulb treatment of limestone. Next, diclone 2,3-dichloro-1,4 naphthoquinone. It is used for seed treatment and also foliar spray against many plant diseases. Phenols. Phenols have shown expansional qualities as bactericide, but as fungicide, their use has been limited. It has been used as foliar fungicide and it in seed treatment. Heterocycling nitrogen compounds. These compounds, these compounds have valuable fungicide properties and are used as foliars, protection and eradication of fruits and vegetable. Captain, the common name of trichloromethyl and theo4 cyclohexane 1,2-dicarboxamide. It is commercially sold as Captain 50W and fungicide, which act as symmetrically and difolinate difolotian N11 tetrachloroethyl sulfonyl 6. This one is the difobant as properties similar to Captain. It is good fungicide for the control of early and late blight of potato and tomatoes. Benzene compound. Many benzene compounds are toxic to microorganisms and have been developed as fungicide. It is used as a dormant spray for control of many disease of fruits and fruit trees, ornamental plants. Chloroneb. The fungicide chloroneb 1,4-dichloro-2,5-dimethoxybenzene was introduced for the control of seedling disease of cotton. This is a systematic fungicide. Dexon. This is the P-dimethylamine benzene, diazosodium sulfonate. It is used against soil-borne fungi, causing root rot and damping of disease of plants. Systematic fungicide. The development of systematic fungicide such as benomyl, azothine, tetrazole, etc. are used to treat many plants after infection. Systematic fungicides are observed and tetrasolicated within the plant, restriction the spread and development of pathogen by direct or indirect toxic direct in toxic infection. Infection, toxic infection. This one is the main source of the control the diseases. This one methyl benzamide carbonate, marked tetrazole. This all things antibiotics also. Antibiotic have been developed to control various plant disease. Most of the drugs observed by the plant and translocated like systematic fungicide, streptomycin, causing against a variety of bacterial pathogen. Tetracycline is able to control control the growth of certain mycoplasma and cyclohexamidine effective in the control certain fungal diseases. Immunization measures based on the ability exempt infection of disease by a pathogen. It is achieved by two ways. One is the biological control, second one is the disease resistant. The control of disease by living organism is called the biological control. Biological control, the survival activity, pathogen is reduced through the agency any other living organism except man himself. This result reduction of disease incident caused by the pathogen. Many microorganism, pesticide compete and antagonize other microorganism. Biological control is based on these properties. Microorganism, antibiotics,